Good morning, all of you. In this session, I'm going to discuss in the module 4 the continuation of this problem. In this session, I have to solve two more problems. Okay, then I will finish this module 4. Then I will move on to the last module, that is what module 5, that is what air compressor. Okay, now I'll read out the problem on refrigeration system. Okay, now a refrigerator using ammonia as a refrigerant works between 30 degrees centigrade and minus 10 degrees centigrade. There is no superheating or undercooling. Calculate the COP of the cycle if the vapor is dry saturated at the end of compression. If the actual COP is 60% of ideal COP. Determine the power required to run the compressor. The refrigerating effect to the produced is 5 times. If the refrigerator produces ice at 0 degree centigrade from water at 25 degree centigrade, what quantity of ice is produced in 10 hours? Enthalpy of fusion of ice is 335 kilojoules per kg. Okay, this is the problem. Based on the problem, we have to write down from the properties from the thermodynamics data handbook. From the thermodynamics data handbook, ammonia refrigerant from the table B1, page number 26. Okay, use the thermodynamic data handbook Nijaguna and Samaga. Then that is the value of T2 is 30 degrees centigrade, lowest temperature is minus 10 degrees centigrade, corresponding 30 and minus 10 degrees centigrade. From the data handbook for ammonia as a refrigerant, we have to, from the table B1, we have to write down all the values. That is the value of HF, the value of Hg, value of HFG, value of entropies, that is what SF, SG and SFG. Okay, then afterwards we can note down all these values. Then we have to find out the value of entropy, that is what S1. That is from the TS diagram we have to write down. Here there is no subcooling and undercooling is there. That means what, it becomes a saturated condition. Then we have to write down the simple TS and pH diagram, simple pH diagram. Okay, now based on this TS diagram, we have to find out the value of S1 and S2. S1 is equal to S2. Then it becomes a dry saturated condition. The point 2 at the exactly at the saturated curve. That means what? That is a dry saturated condition. It becomes Sg2 is equal to Sf1 plus X into Sfg1. Okay. Then we have to substitute all these values. Okay. Then you should find out the value of X. X is equal to 0.9. Then enthalpy at point 1, that is what H1 is equal to HF1 plus X into HFG1. Then you can substitute all this value. You should find out the value of H1, that is about 1302.32 kilojoules per kg. Then H3 is equal to H4 is also equal to the saturated liquid. It becomes the value of HF, that is what 322.9 kilojoules per kg. That H2 is also equal to the Hg2, that is a dry saturated steam. Then we have to find out the refrigeration effect. The refrigeration effect will be produces in the process 4 to 1. Then I have to write down the expression H1 minus H4. Then you can get the value of 979.42 kilojoules per kg. Then compressor work WC is equal to H2 minus H1. It becomes 165.58 kilojoules per kg. Then theoretical COP is given by COP of theoretical is equal to refrigeration effect divided by work supplied. Already we have calculated refrigeration effect, that is what 979.42 divided by work compressor work, that is what 165.58. It becomes 5.92. Then actual COP is equal to 0.6 into COP of theoretical. It becomes 3.55. Then COP of actual is equal to actual refrigeration effect per minute divided by actual work supplied per minute. It becomes actual refrigeration effect per minute is equal to, they are mentioned it 510, then 5 multiplied by 210. 110 is equal to 210 kilojoules per minute. It becomes 1050 kilojoules per minute. Okay, that is what W work done, actual per minute is equal to refrigeration effect actual divided by COP of actual. It becomes, substitute these values, 1050 divided by 3.55, it becomes 296 kilojoules per minute. Then power required is equal to 296 divided by 60, it becomes 4.93 kilowatt. Then how much amount of heat will be removed from the system? You have to get the 1 kg of each kg of ice. Then how much kg you can multiply the things. Okay, now here heat carried away to form each kg of ice is equal to mcp into delta t plus m into latent heat of ice. That we can calculate. M we can take unit mass, then it becomes cp into delta t plus latent heat of ice, m into latent heat of ice. That means cp value is equal to 1.005, delta t is 25 degrees centigrade minus 0 plus 335 latent heat of ice, it becomes 360.13 kilojoules per kg. Then ice formed per hour is equal to actual refrigeration effect per hour divided by heat carried away. Okay, that is calculated by 1050 multiplied by 60 divided by 360.13, that is about 175 kg per hour. Ice formed in 10 hours is equal to 175 multiplied by 10 hours is it becomes 1750 kg. Okay, this is the problem. Okay, all of you can go through. In my notes is available this problem. Once again, you can go through all these things. Okay, now the last problem of this module 4. Okay, I'll read out this problem now. A ammonia refrigeration system works between minus 8 degrees centigrade and 26 degree centigrade. The vapor being dry at the end of compression. The refrigerant is subcooled to 5 degrees centigrade before entering the expansion valve. Sketch the cycle on TS and pH diagrams. Find the COP. If the capacity of the plant is 12 tons of refrigeration, find the mass flow of refrigerant. Okay, this is a problem. Okay, based on this problem, from the ammonia, once again, that is a as a refrigerant we are using in this problem. So that's why the properties of for ammonia from the table 1, that is page number 26 from thermodynamics data handbook, we can use this data. That is T1 is equal to minus 8 degrees centigrade, T2 is equal to 26 degrees centigrade. You can write down these values of HF, HG and HFG, and entropy values SF, SG and SFG values. All the values you should note down. Okay, already you know this how to read this thermodynamics data handbook. Okay, almost all the students you are having this thermodynamics handbook. We are using this handbook in basic thermodynamics in 3rd semester. So that's why you should take this handbook and read out all these values. Then we have to find out the value to find the dryness fraction at point 1. That you can calculate. S1 is equal to S2 is equal plus SG2 is equal to SF1 plus X into SFG1. Then we should calculate here S1 is equal to S2, that is what the value of 5.024, it becomes SF1 point. You can substitute all these values, then you can find out the value of X value. X value is become 0.914. Okay, now here in this, what happens here in the TS diagram, they have the minus 8 degree and 26 degrees centigrade is there. Here the subcooling will be taken, the subcooled. While subcooling, we have to write down this subcooled in the 3 to 3, that curve which will be leaving from 3 to 3, it becomes 3 to 4. It is what 3 to 4 should be existing here also in the pH diagram. 3 to 3 it will be existing, it will be subcooled. The saturated here is there, the 3 that should be saturated liquid, either water. Under that one we have to make it subcooled into the 3 up to 3. Okay, so that's why this is the way of writing the pH and TS diagram. Already we know these case studies. In the case study we have discussed about this case study also, that is subcooling, how to write down this pH and TS diagram. Just you can go through that one in the theory, you can get the idea also. Then you should find out the value of H1. H1 is equal to HF1 plus X into HFG1. You should calculate the value of that is about 1323.45 kilojoules per kg. Then if you have to find out the value of enthalpy at 0.3, you can calculate the enthalpy of 0.3. That is what H3 is equal to. H4 is also equal to H3 dash minus Cp into T3 dash minus T3. we have to calculate what is the value of T3 dash means that is a saturated liquid, saturated water. You can take the value of HF2 value. What is the HF2 value is there? You can take down that value, you can substitute it here. You can get the value of H3. H3 is become 309.77 kilojoules per kg. Then we have to calculate refrigeration effect. Refrigeration effect is equal to H1 minus H4. Then you should calculate here, that is the refrigeration effect is 1013.68 kilojoules per kg. Then compressor work is equal to, that is a 142.15 kilojoules per kg. Then COP is equal to 7.13. Then mass flow rate, MR is equal to 210 multiplied by corresponding tons divided by refrigeration effect. That is what 210 multiplied by 12 ton of refrigeration divided by 1013.68. It becomes 2.49 kg per minute. Okay, like that we can solve the problem based on the conditions. Okay, different condition. This is what the saturation condition. This is what subcooling of the refrigeration system. Okay, this is all about the module 4. Okay, go through my notes. Everything this will be available in the notes. Okay, be concentrate the all the classes whatever covered, all the staff members. Okay, all of you should be refer the notes and also the classes whatever they were covered it, and you should write down the assignment, everything whatever the instruction given by the faculty members, you can follow the instructions. Thank you one and all. I will stop it here. Okay, the next session I will continue of module 5, that is the last module. Okay, have a good day. Stop it.